So here's the fourth part for the notes, and I rambled a little bit in one of the other sections about percentiles and percentile ranks. So just to give it a little more clarity now, the notation for percentile rank is the letter P and then a subscript for the particular percentile you're looking at. So the 70th percentile will be denoted by P subscript 70. So how do we find the 70th percentile? Well, you start by sorting the data values. So here we have the sorted ages of acting award winners on the left-hand side. And you can see that we've got them in order from smallest to highest. Okay, so they're ascending order. Now you can do this on your TI calculator. You'll notice that if you access Stat Edit, one of the options is Sort A. Sort A means sort in ascending order. And another option is Sort D, and that is to sort in descending order. So Sort A will sort your data for you if you have it in a list, and then you access the list, and the list will then be sorted. Okay, so the 70th percentile is the data value that divides the lowest 70% and the highest 30% of the scores. So you figure out how many data values there are altogether, and in this data set there are 36 data values. So how many would be in the top or the lowest 70%? Well, 70% of 36 is 25.2. So P70 would be the 25th data value from the lowest in the sorted list, and that turns out to be the data value 58. So P sub 70 is 58. So a person scoring a 58 has a score that's better than 70% of the people in the data set. Now, there's a procedure in the textbook for determining percentiles. I'm not as concerned about you being able to determine percentiles as it is that I want you to understand what the percentile rankings mean. On the other side of this slide, I'm working a little bit with the 30th percentile. Students get these two things confused. Just remember that the percentile ranking is the position that you're in, which marks off this percent of the data and the rest of the data. So if you're at the 30th percentile, that means 30% of the data is below that number and 70% is above that number. If you're at the 70th percentile, that means 70% of the data is below that number and 30% is above that number. So make sure you understand that distinction. Of course, the 50th percentile is the data value at the center, or the mean of the two data values in the center. So exactly half of the data will be above the 50th percentile and half will be below the 50th percentile. So the 50th percentile is the same as the median. The 25th percentile is the data value that has 25% of the rest of the data below it, and so that would not be a very high percentile. The 10th percentile would be the data value that has 10% of the data below it, and of course 90% would be above it. So you can answer the question how many percentiles there are. You can think about that, which is what I'd like you to do before you look at the answer. It's in the definition of percentiles on page 116. So think about how many percentiles there are and then see if you're right by looking at page 116. Quartiles are very similar to percentiles, except with quartiles we simply divide the data into 4 chunks, and so there are 3 quartiles. The first quartile cuts off 25% of the data. The second quartile cuts off 50% of the data, and so it's the same as the median. And the third quartile cuts off 75% of the data to its left. So what you should be able to figure out is which percentile corresponds to each quartile. So what P sub what is the same as Q sub 1, P sub what is the same as Q sub 2, and P sub 3, what is that the same as? P sub what is the same as Q sub 3. I've already told you that Q sub 2 is the same as P50, so you can figure out the other two. Now the TI calculator gives you, well actually what I have here is the StatDisk output for the five number summary box plot. So when you get a box plot, either by using StatDisk or by using the TI calculator, you get these 5 numbers on it. And this is what these 5 numbers are. This number is the minimum x value. So here the minimum x value is 59.1. This number over here is the maximum x value. So once you know those two, you can calculate the range. And then these two numbers on the edges of the box, those two numbers, 61.5 and 64.95, those are quartile 1 and quartile 3. And then this vertical line in the not necessarily in the center of the box, but inside the box, that vertical line represents the median, and that's quartile number 2 and also P50. Notice that this box plot has a pretty symmetrical distribution. It looks like it's almost a normal distribution, whereas this box plot has quite a bit of skewness. Most of the data is concentrated at the lower end, and then we have this long tail out to the maximum x value. So you see this one is skewed to the right. And you can tell that by looking at the box plot. So this one is positively skewed. I don't know if I said positively skewed, but that's what I meant to say. And what I'd like you to think about is, what would the box plot look like if you had a negatively skewed distribution? So just make a little sketch of what you think that would look like. Just a box plot for a negatively skewed distribution. Okay, so here's an example of a problem type, and what I would like you to do is practice using the 1VAR-STATS key on the TI calculator to answer this question. So you're going to do example 5 here, where we have a list of the recorded speeds of randomly selected cars on a section of a highway in Los Angeles that's known for speeding. It has a posted speed limit of 65 miles an hour. And so what we want to do here is find the 85th percentile of this data, find the 85th percentile of that data. And given that speed limits are usually rounded to a multiple of 5, what speed limit do you think is suggested by these data, and explain your choice. And then what we want to know finally is whether the speed limit on Highway 405 conforms to the 85th percentile rule. So look for that in the textbook if you have difficulty with it, and follow along with the solution, and make sure you understand it, and make sure you know how to use 1VAR-STATS on the TI to find out as many of the answers to these questions as you can. Let me know if you have questions about it. So here's how you would start out doing this problem. I've showed you that you can easily get the box plot using the TI calculator. So figure out how to do that. There's a video on Sophia that explains that process. These are the 2 screens for the 1VAR-STATS. This arrow pointing down means if you press the down arrow navigation button, you get more information. So what you do is sketch that box plot right here, put it on paper, and then put the 5 numbers from the 5-number summary where they should go on that box plot picture. So locate the minimum, the maximum, and the first quartile, the third quartile, and the median on that picture, on that figure. So if you remember the empirical rule and the way a normal distribution looks, and all these nice standard deviation mark-offs on this nice curve, you know what all those percents add up to, of course. They add up to 100%, and that's the number 1. Right? 100% is the number 1. That's what all those percents add to. So that 1, that this 100%, represents the area of the shaded region. And that goes hand in hand with our work, I believe it was in Chapter 2, where we related areas to probabilities. And so you can find out which percentile each of those vertical cut lines corresponds to. I'd like you to think about that question and see if you can figure out what percentile is represented by that position on the horizontal, and what percentile is represented by that one. I'll just give you a hint. I'll do this one for you, say, and maybe I'll do that one as well. Remember, this is x bar, and in a perfectly symmetrical normal distribution, x bar is the same as the median, and so that would be the 50th percentile. And it's the 50th percentile because that's 34%, 13.5% plus 2.4% plus 0.1%, I believe that adds up to 50%. Yes, it does. So now maybe you can figure out what percentile is represented by this vertical line, what percentile is represented by that one, and what percentile is represented by that one. For this one, you would just take that mark off right there, make a vertical line, and then figure out how much, what percent of the area is to the left of that value. It's just like reading that normal curve. So you just add up these percents, and that will tell you what the percentile is for that particular spot, which is, of course, the spot with a z-score of 1. I would like you to read this paragraph about outliers. It's important to always keep in mind that when you're analyzing in data, you should identify and consider outliers because they can strongly affect values of some important statistics. Remember, the outliers affect the mean and the standard deviation quite a bit. And so they can also strongly affect important methods discussed later in the book. Anyway, go through that part and make sure that you're always aware that there could be outliers affecting your calculations. The chapter opener of this text began with a question about whether women really do talk more than men, and we have these frequency polygons for the number of words spoken by men and women. These came from chapter 1. If you're not convinced by looking at the polygon that there's not that much of a difference, you can look at the box plot and compare those two data sets by their box plots, and you'll notice that the strict numbers might not be might look quite different. The strict numbers on the ends might look quite different, but in actual fact, the data are pretty much distributed the same way between the men and the women and the number of words that they speak. You can see that the amount of variation is about the same, and you can also see that the medians are pretty much in the same position. So you can tell from the box plots, you can make a valid conclusion about whether or not women talk more than men. So think about that, and I think you should be ready to post lots of problems now. Thanks.